Hi there, students. This is Mr. Dunaway. Welcome to the next part of Chapter 7, Section 1, the Distributive Property. We are at a place now where we are going to move away from the algebra tiles. You will be allowed to use those. Some of you might want to continue using them to make your life a little bit easier. I recommend that you do if they're helpful for you. The main thing is we want you to be able to use this property correctly when we work on things. So go ahead and put your name on your notes and let's go through this. It should go pretty quickly for us, I hope. Put your name and the date on it. And real quick here, what we're doing here is we're dealing with things called numerical expressions. And some expressions can be written as equivalent expressions when they have the same value. And the distributive property allows us to do this when we have a variable inside of a parenthesis. And that's what they're trying to show you here. It's called the distributive property, as we've been saying it for a few days with the algebra tiles. But here's an explanation of it in the words. It says to multiply a sum or a difference. Okay, that means it can be addition or subtraction by a number. What we do is we multiply each term inside the parenthesis by the number outside the parenthesis. Okay, now you've been doing that with the algebra tiles. All right, and here it is written in symbols for you. Let's just say you had some number out here, A, and inside you had B plus C. So that means, if you recall, with the algebra tiles, we would make this many groups of those particular shapes. So it's like we took B times A, we made AB, that means A times B, and then we also took A times C, and we have AC, and then for you it looked like probably like 3x plus 4 or something like that. And again, it doesn't matter if that sign is addition or subtraction, we can do that, but that's the rule. Okay, that's the rule. A times, now A just represents some number, times the numbers that are inside there being added. You just multiply that times that, you get AB, and then that would maybe be a number depending on what they were, and A times C would give you A times C. And then here are some examples written in just numbers. So it might be a little confusing in the rules like that. Hopefully it makes more sense to you because we've worked with the algebra tiles. Let's take a look at number 1 here. If we were going to build this, you recall you would have built 6 groups, but remember when I originally taught you, I told you that that sign right there forces those signs to switch. Now if you look at this, remember that number in front of the A is a 1. If it doesn't have a variable or a coefficient written down, it's 1. So if I take negative 6 times 1, you'd have negative 6 times A. All right, easy enough. Now if you take that negative 6, and I would like you to draw those arrows on your paper just like I'm drawing right there. And now if I took negative 6 times 8, that would be negative 48. So if we created these groups, 6 groups of 1x is what we use, or 1a plus 8, you'd have 6 red variables, and you'd have 48 red squares, and that would be your answer right there. So we can save ourselves quite a bit of the time when we understand the property. Let's take a look at number 2. Number 2, here's 4. That means we have 4 groups of 1. Okay, so that's 4 times 1 would be 4. Plus 4 groups of 9x. So that means you'd have 9x down, but you'd have 4 groups of them circled, and that would be a total of 36x. And we could rewrite that. And usually we like to rewrite with the variable term first. Now don't add those numbers together because you can't do that in algebra. If you have an x and a number that's not x, you can't add those together. It's just like we didn't combine the different shapes in the algebra tiles. All right, let's jump down to number 4 here, because I often get a question, well, if you notice, what's weird about number 4? That 2's on the back side. It doesn't matter that the 2's on the back side. It's still 2 groups of these 2 things here. So let's distribute that 2. We're just going to draw the arrows this way. Please draw the arrows just like I'm doing. 9 times 2 is 18. M plus 2 times 10 is 20. So there you have it. All right, there's 3 examples I did. I'd like you at this point to stop the video and see if you can do the next 3 without my help, and I'll come right back here in a second. When I come back, I'm going to show you the solution. So hit pause now and see if you can work them. Okay, there are your answers right there. So hopefully you stopped it. Number 3, did you get negative 30n plus 42? You should if you multiplied 6 times negative 5 and 6 times 7. And just do not add those terms together. Don't put them together. You can't do that. Just picture the algebra tiles, different shapes. You cannot add together. Number 5, I got negative 24n plus 32. And for number 6, I got negative 8 plus negative 32. Or you might have said negative 8 minus 32, which is really the best answer, but I'm not that picky about that. All right, we're almost done here. Nice short night for you, hopefully, but I want to turn to the next page. I want to prove this to you because hopefully this will be valuable for you. I want you to see that this is not something that's just made up, that on all of those problems on the front side, that these are equivalent expressions. Okay, on number 1, this expression with the parentheses is the same as that expression, and it's the case with all of them. And number 3, that expression, the question, is the same value as that right here. I'm going to prove that to you on this page right here. Let's and here it is. Here's proof. Solve the following expressions using the order of operations. Okay, let's forget everything about the distributive property and let's just solve this. All right, if we go back to the order of operations, PEMDAS, please excuse my dear Aunt Sally. We know that we have to do what's inside the parentheses first. Okay, if we did that, 5 plus 4 would be 9. 3 against the parentheses means multiply, you have 27. Okay, easy enough. All right, 27 is the right answer. Now what I'm going to do on the next part right here is I'm going to solve the same problem using the distributive property. Now my whole point, what's the point? Is that to show you that this is equal if we do it the old-fashioned way, which is fine when you can, or the distributive property. So we want to see that the distributive property is just another way of writing the same value. Alright, so we're going to see if we get the same answer, but we're going to do the distributive property. And remember the distributive property? Yeah, you've been doing it. If you just did the other side, you multiply those two right there. Okay, this times this. Okay, if I did that, 3 times 5 is 15. And then you take this times this number here. 3 times 4 is 12. Add those together. Well, 5 plus 2 is 7. 1 plus 1 is 2. Guess what? We got the same thing. See, that's the whole point I was trying to make. All right, it's the same value. Also remember that this can be subtraction. And if it is a subtraction, you just leave subtraction in your answer there. Okay, so the whole point is those values are the same whether you use the distributive property or you do it the old-fashioned way. The problem in these questions on the front page, you're not allowed to add the variable term plus the number without the variable. You can't do that in algebra. So we'll talk more about that as we progress. That's all the notes, so congratulations. One video, not a bad night. Bring those back to class and we will get going tomorrow.